Okay, so these videos I'm going to show you how to put together some of these drawings that are available in the week 1 section of the website. So as you know, all you have to do is click on the image that represents that drawing. It's going to bring up the drawing in PDF format. Nice thing about having the dual monitors in HT120 is to give you the capacity to look at the drawing on one side and be able to model on the other side. It's going to be real convenient for you. So one thing you want to do with these drawings, and keep this in mind because later in the quarter you're going to be creating drawings like this, is you want to make sure it's readable and understandable and it's got all the appropriate information in there. You're going to need to have somebody build this, or in this situation, to model it. So go ahead and read the drawing. You have the name of the whatever part's going to be. That's going to be important, and maybe some secondary names, and then maybe broad categories in here too. So we have a Koku Baby Deluxe toy in here, which is the cone. It's going to be the bottom cone. There's going to be some fun stuff that's going to go inside of that, but we're just worried about the cone right now. And sheet scale is down here too. Sheet size is A size, but typically in the lab we're going to be creating B size paper. Tabloid size drawings, which is half size D size, which is typical engineering sizes, which is going to be 34 by 22. So we're about quarter size here in regard to paper size, but the scale is going to be 1 to 2. So kind of look this over, think about what you need to do. What we're going to be starting with is going to be a simple cylinder that we're going to be putting a draft on in order to provide that angle to make a cone out of it. So look for that information you're going to need to start with. You're going to read this through and kind of look at things. Sheet notes are always going to be green. The text is going to be red. And with the red text, both the sheet notes and the red text in here for the annotations, for the dimensions and stuff like that, are going to be grayscale when you print this out in black and white. So that's the reason why these are different colors. It also makes it a little bit easier to navigate. So if you're looking at dimensions, look at everything that's red. If you're looking for notes, look for everything that's green. And then the object lines, remember that. There's probably a test question a little bit later. Object lines are always the darkest things. And then when you're looking at this, you'll notice that we have some dash lines in here too, and those are called hidden lines. Yeah, dash line is a hidden line. So if you're looking at this from the front, as you would like maybe over in this orientation over here, isometric, that's a little bit of the front, a little bit of the right, a little bit of the top. When you're looking at it direct on like this, you can tell it to have the hidden line showing. And these hidden lines represent an edge that's not apparent in the front-on view. So that's what those means. That's what you're looking at. So we're going to be building this as a cylinder. We're going to put a draft on it to make a cone out of it. And we're going to start with an initial diameter over here of 40 millimeters. And then it's going to be 170 millimeters tall. And we're just going to go ahead and build it from there. Other things you're going to need to know, you're going to be able to have to dig this out of the title block. So you want to make sure you understand the units, which are in millimeters, so you're going to look at that over here. Drawn by, that's something that would come later. We'll talk about that later. Print date, version date, stuff like that. Material, this is something you're going to need to note here too. You want to make sure you put the proper material in there, otherwise you're not going to get the right weight. So we're going to put this off to the side. We're going to begin to model it. We're going to go ahead and open up, go to the open, and we're going to go to our SolidWorks template files. So I'm going to go in here and go into the appropriate class section that we're going to be using. And we want to make sure that when we go to the class design, you have your template files in here. You're going to choose the appropriate one. So I'm going to be using not inch pound second, but millimeter gram second, ANZ-B. Not drawing, but we want to look for the part drawing over here, which is going to be this guy down here. So part-MMGS, we're going to go ahead and click on that and open that up. So now we have all the settings in here that we want. We just need to begin to draw. So we're going to start. You got to think about this and read your notes. Initial cylindrical extrude up from the top plane. So we're going to sketch in the top plane, and we're going to sketch with an initial diameter of 40 millimeters with a draft angle of 14 degrees at 170 millimeters. So let's pull that aside. Start with the top plane. Go to sketch. Go to circle. When you do that, it's going to correct itself and make itself parallel to the screen. I'm going to sketch a circle out here, and you'll notice that there's kind of a value next to the cursor. You don't have to worry about that right now, but we're going to go ahead and put a dimension on there by selecting Smart Dimension up here. Drop that in an arbitrary location and give it a specific value. Now you notice it's black. It's fully defined. Don't need to do anything further with it. And do not do this like you did in AutoCAD. Don't take that dimension and delete it, because now that circle has the capacity to move around. You don't want to do that. You're going to get some errors. So Control-Z a couple times, And now we have that initial diameter. So now we're going to go ahead and do an extrude. Extrude boss base. Properties Manager pops open. We're going to make that 170 millimeters, so it's going to go way, way up. Now we have a draft angle. So this is where the draft angle comes in. It's this option over here. We're going to go ahead and click on that. We're going to make that 14 degrees. We did this in class, remember. Kind of had a small little cone in here, but we can do and select draft outward and go to the green check mark. Now we have that in place. So that's not really quite the look that we want. We want to define the material. So we're going to right click on that material. Go to Edit Material. We probably should have done that first. We'll do that first next time. Because typically what you do in a Properties Manager or a Feature Manager, you start from the top, work your way down to the bottom. And if you do that, you should be able to cover everything. So we're going to be looking for woods down here. There's woods. Select Mahogany, Apply, and Close. Now we have that in place. So just to double check our mass properties, you want to go up here to the Evaluate tab in the Command Manager, go to Mass Properties, go to Options up here, Custom Settings. We want to make sure we're out to 3 decimals, and take that toggle, move that up to the highest level. That's important to do. If you have it down at the lower level, it doesn't calculate it as precisely. You're not going to get the same numbers that I got. So 3 decimal places, toggle up to the highest, go to OK, and then look at the values you have over here. You should be looking at 591.718 grams. And according to our drawing over here, 571.718 grams. If you get that, you're all set. You're ready to go. Go to the next one. So let's close that. Let's go to our fillet, and let's take a look at our drawing in regard to the fillet. Fillet radius is right down here. R implies radius. The diameter symbol implies diameter. It's easy to get tripped up on those. So if it's not quite a full circle, SolidWorks is always going to think radius. If it's a full circle, it's always going to think diameter. So keep that in mind, and just make sure you're watching this. That's going to be a test question. So remember, diameter is for anything circular is going to come out. SolidWorks is going to label that as a diameter. I'm going to write this down. And anything that is not quite a circle, a radius, or not a radius, but an arc, it's going to consider that a radius. And we'll put that as a test question. You'll see that on Monday. Okay, so we're going to be looking for that radius on the bottom. It's going to be 15 millimeters. We're going to select the outside edge. Here's what you do. You go to the Features tab up here. Go over here to Fillet. And Items to Fill. We're not going to fill that in yet, but we're going to go ahead and put in the value down here for fillet parameters. We're going to kind of keep everything on a default setting because there's a lot of options in here. And then we're going to go ahead and click on this edge down here. You notice it turns orange as a pre-selection. Click on that. You'll see it as a preview. Make sure you can see the preview by clicking that radio button in here. And you're going to see that. And if you go to the green check mark, that should be ready to go. So the next element in here is going to be the shell. So talking about the suggested order down here. We're going to start with the basic features we did. We're going to put the fillet in there, and then we're going to put in the top shell after the fillet, which it says over here, and then we're going to put in the bottom hole, and then ultimately we're going to get that mass property. So the top shell, look at the shell thickness in here, go into your drawing, take a look at what you need to do. This is the dimension we're looking at. It's going to be 5 millimeters. So now we're going to put that shell in here. So again, we're up to features. Go over here to shell. We're going to go ahead and click on this surface up here. We're going to provide a shell value of 5 millimeters. So we're going to go to the Properties Manager over here, 5 millimeters at the top. Click that surface. The surface is going to be open. Everything else is going to be closed. Everything else is going to be given a thickness to it. And it's going to kind of scoop it out. So a green check mark. Okay, green check mark again. And now we have that shell. Okay, the last thing we need to do is put in that hole. We're going to go ahead and click on the surface for that. And before we do that, let's take a look at our drawing one last time. We have this dimension down here for 27 millimeters for the bottom hole. So let's go ahead and do that. We're going to go ahead and click on the surface. We don't have to click on any planes now to do this. So we already have surfaces in our model. We're going to go ahead and borrow those surfaces. We're going to go to Sketch, go to Circle, start with the origin so it stays right in the middle. If you don't do the origin, you're going to have to define that in a different way, and probably you're not going to get the right mass properties. We're going to sketch that out. We're going to make that really big, just to exaggerate it. Now we're going to put a dimension on it. We're going to make that 27. So diameter dimension like this, it could be with leader lines if you like, but if you want to change that, if you click on that dimension, go over here to leaders, we're going to make that over here to be the diameter leader and kind of pull that off to the side. Now that we've done that, if we go to features, extruded cut, I'm going to make sure you have it on the correct face. If you don't have it on the correct face, let me know about that, and I'll show you how to change that. But we're going to make that through all. So it goes through everything in case we change the size of our model, change some of the other parameters. It's always going to be through all. And go to the green check mark. Now we have that in place. We have a little hole in the bottom and a truncated cone with a fillet on the bottom and shelled on the inside. Let's see, as a capstone to this little video, let's go to mass properties and see what we got. So we have 126.879. We don't have to go back to options. It's not going to change from what we had set before. So again, 3 decimal places, toggle up to the highest. And let's see if that's correct to our drawing. It says it should be 126.879, and that is correct. And then center of mass too, if you want to check that, that should be the same too. So it doesn't change into X, doesn't change into Y, but now we have an offset of 101 millimeters, 0.070. And that looks like it's the same over here. So what does that mean by the center of mass? Well, if you think about this, let's pull this off to the side. If you look at the triad down here, we build everything off the front, off the top plane. So everything off in the Z direction off to our right, the X direction off to the back. It says right in the middle of that, so it's going to have 2 zero values to it. The only change we have is the center of gravity, which is this symbol over here, is 101 millimeters, and a little bit more than that off the bottom. And that's where the center of mass is going to be. So it goes up 170 total, so it's a little bit more than halfway. And that kind of makes sense since you have a little bit more material up top than you do on the bottom because of the size and the shape of our object, which is a truncated cone. So that is how you build the Koku Deluxe Baby Toy Bottom Cone.